I think Anjali, we can start. Hello, good afternoon, everyone. Welcome to today's webinar on scope and development in plant-based protein ingredients processing by Professor Bhavesh Jani. I'll give a short introduction on Chamber for Advancement of Small and Medium Businesses. And please mute yourself. If you have any questions, you can ask at the end. We'll have a short Q&A session. So Chamber was founded in 2020 in the height of pandemic, and it was officially launched on March 2021. So our mission and vision is to make MSME more resilient, make them more stronger backbone of Indian economy. Our objectives are basically, suppliers, traders, consumers, etc., to educate and empower them via various programs, create awareness about government scheme, market linkages, empower farmers to become entrepreneurs, support women entrepreneurs, support them with financials and such educating webinars, etc. Next slide, please. We are blessed with a great advisory board where consists of Professor Smita, Lele ma'am, Kondekar sir, Kamble sir, Pramod Raghav sir. Our core committee is where Prabodh Harde sir is the chairman, Nilesh Lele sir is the founding president, and conveners all over India. Working in various sectors, empowering women entrepreneurs. We have a quarterly magazine, Purna Brahma. Next slide, please. Some initiatives. So we have knowledge series and trainings where we conduct online webinars. We have around more than 100 webinars. We have a YouTube channel where 10,000 plus have already attended and subscribed. We have a startup buddy program where we help to build a network within professionals. We have a e-learning portal, Food Tech Pathshala, which is a skill-based e-learning. More than 20 courses are uploaded. So basics like finance for non-finance, R&D, which you won't find in your syllabus. It's more industry-based, practical-based. So you can go and check that out. We have a quarterly magazine, Purna Brahma magazine. Our next issue is Divyang J. It's a special issue celebrating hardship and successes, presenting inspirational stories. Government scheme. Okay. So some of the initiatives are study tours and exhibitions where students in pandemic we had an online factory visit, and same we are doing it offline right now. A woman cell which has been created to handhold women entrepreneurs. I urge everyone to please take a membership, which is 2,500 annual membership. And some of the benefits are you can use our Mumbai office for your businesses, for your meetings, and we are associated to various events and exhibitions, so you can get a free or subsidized a support partner. You can be free or subsidized. You can enter to that exhibitions and events. Next slide, please. Some of the events you can just scroll forward. So as I said, we are partnering with various exhibitions. You can be a part of these exhibitions. Thank you very much. If you have any queries regarding subscription or magazines or membership, you can contact our team, Prajakta Kende. And thank you so much. These are our social media platforms. To get updated about upcoming events, you can follow us. Please subscribe our YouTube channel. And I'll request Anjali to please introduce today's speaker.
Yes, thank you. Bhavesh Kumar Jani sir is Assistant Professor and Head in Department of Food Process Engineering, College of Food Technology at Sardar Krishi Nagar, Dantewada, Agriculture University, Gujarat. At present, sir is focused with the development of peanut and amarna protein isolates and hydrosylates with variable functionality suitable for the preparation of textured flour, thickening, emulsifying, flavoring agent, and plant-based food and beverages. He is uplifting chemical-free farming by supporting and consulting farmers. Professor Jani has successfully been serving for entrepreneurship development and post-harvest management. He is also a reviewer and editorial board member for different journals in the field of food processing. He is a recognized scientist in the field of plant-based protein processing segment. I would now like to welcome Professor Bhavesh Kumar Jani, our speaker for today. A very warm welcome to you, sir. Over to you, sir.
Thank you so much, madam. Let me share my screen. Is it visible?
Yes, sir, it is.
Thank you. A very good afternoon to one and all. And thank you so much, Chamber of the CASMB, in short, I must say, because everyone has taken their time to introduce myself as well as the Chamber. So nice initiative by the Chamber and the leaders, particularly Nilesh sir and Umut sir and everyone. Recent development in terms of food processing sector is more focused on nutrition and supplements. So in case of nutrition, people are looking for, if capsule is available to eat, nobody is going to eat the whole dish. Similar trend is going on in the ingredients development. If you have a proper ingredient in your hand, we'll discuss how proper ingredients can be defined. Then only you can develop a proper nutrition pack of product. So today we are to have some briefing on plant-based protein as an ingredient. What are the other alternative proteins in the sector, and how these ingredients are being processed for a proper input development for alternative protein-based food product processing industries. So this picture elaborates everything about the protein sources. It includes all your plant-based alternative proteins other than those, as well as your animal-based protein, which are existing till years. In case of plant-based protein, I must say it is something which it can be available from the plant. But not only plant-based protein are in the market, and not only the issue is of protein. The issues are associated with the number of activities which are being done for the grazing the animals and the animal side. So some points are enlisted here. The increase in GHGs, the land use pattern, the fresh flow water withdrawal, and majority of, you can say, the sources are being utilized by almost half or more than that for agriculture, but more than 94% of the global biomass is acquired by the livestock itself. So in case of agriculture, even I must say, almost 30 to 35% of the mass of the biomass which is generated by agriculture is utilized for grazing the animals. And these days it is a typical issue, particularly when it comes to greenhouse gases, agricultural land availability by time, and in future to feed the whole generation, upcoming generation of, you can say, billions of people in the world by 2030 or 2050. And other than these are the fresh water availability, that is also one challenge. So looking all those aspects, world is now about to find out some solutions by which animal-based food dependability can be reduced in all the aspects. So before that, before coming to aspects, the first and foremost thing that came into the picture when it comes to commercialability, particularly, that is your three phase for sustainability of any food product, that is taste, texture, and the cost itself. So majority in the different region, there is different requirement. Of course, the cost is or price of the product, the final product is what most important for any of the industry working in any sector. In our segment, I have one parity to show to you that as of now, of course, this plant-based or alternative protein-based foods are, little costlier than compared to the animal-based. But of course, by time, by, somewhat 2030 or 2035, as the animal grazing and animal-based food products are getting, costly. Similarly, your alternative proteins where ingredients are particular of focus in case of cost sensitivity, as researches are being carried out on those aspects, definitely your ingredients will become, cheaper or affordable, and similarly the products. Therefore, there are in this sector 4 kind of proteins that you can see in case of alternative protein ingredients. The first and foremost is the plant-based that we are consuming from thousands of years in our diet. Other than these are the, I can say, fungal or fermented base. It includes all the aspects, I can say, other than alternative to plant and as well as cell culture, fungal or fermentation-based protein processing. And the third phase is the cell culture, which is grown in lab. While the 4th picture I kept intentionally is to show you that all these 3 aspects can be merged and can be introduced as a hybrid protein, which is, customized protein, which is full of bunch of all kind of amino acids and nutrition. So let's see in depth. The alternative protein segment particularly is, foremostly or properly divided into 4 parts, as we have seen, of which the current scenario or the current, industries which are existing player are more than 1100 in the world. The data says, sorry, okay. And more than 90 to 100 big fame companies who are working in case of ingredients processing, while the rest are in the food product development from alternative proteins. Of course, the alternative protein-based food product is not having only protein, but the major portion in case of cost parity is the alternative protein ingredient itself. In India, of course, there are more than 35-40 companies who are good players in case of alternative protein processing market. And like we people, industries somewhat, like your Chamber of Commerce and Good Food Institute, other plant-based associations, as well as the universities and institutions who are working on research development and publicizing and awareing the mass or the industries or the stakeholders about the alternative proteins who are working in it. So we all are the faces to introduce alternative protein in the market. So the existing sources in case of plant-based are the soy and pea, which are in abundant utilization. Of course, there are novel sources which are being introduced and being researched out these days, particularly from the indigenous crops. I considered algae as one of the, of course, it is one cannot say 100% is plant-based, but algae as a novel source I can introduce here. And the number of companies, because it is an old, these ingredient products which are already into market, and good players, foreign players as well as Indian players are there in the market. In case of second phase, where fermentation or microorganism-based ingredients can be considered, basically bacteria or insects or fungus-based protein ingredients are being developed. Sometimes it is directly can be converted to products like tempeh and so products which are rich in protein, and fermentation is already cultured based product is being developed. And the corn, motif foods, and so are the big names who are running in the market these days in the worldwide scenario. The third one and the utmost important these days is being in news is the cell cultured meat products directly from the cells of animal by using this bioreactors, and so the cells are cultured, grown, and in abundant, and finally the products are being produced, which is resembling the most as that of the animal sourced. And there are also a few companies who are working on it. They're already there in the market. The other that I wanted to highlight here, that is the protein composites or hybrid protein, particularly your fermentation and plant-based protein, which can be conjugated to produce hybrid protein of superior quality and free of any kind of animal cells or anything even, which we can consider as a religious purpose. Friends, why it is so to work out on it? Not only, as I told you, the issues, environmental aspects, there are some ethical aspects, there are some religious aspects, there are number of aspects by which introducing alternative to animals in case of particularly meat processing industry are also in consideration these days, and out of which I would consider all these aspects in a single slide to just explain you or give you the idea about how and what is going on in the alternative protein segment. In case of cultured meat, usually animal sources through which the muscle or tissue cells are isolated, and the isolated cells are further introduced to bioreactors where it is propagated for further grown, and the growth is then scaffold for a particular structure that is required by that of the product producers, and then it is after having everything, it is finally launched for a particular cultured or cultivated meat-based product. So the brief process is also given here, as I told you. The next one is the fermentation derived source, and it is of course age-old process where enzymes particularly and some particular bacterial cultures which work on your food in separate different conditions of temperature and humidity and particular pH, and with some sources where carbon and nitrogen are present in a separate vessel or bioreactor, I can say, then is being centrifuged and further it is processed and extracted for having that particular mass of alternative protein. Then the concentration and isolation is being done in the same way as that of the plant-based protein. The beauty of this fermentation derived protein is it can also be valued your plant-based thing as well as cultivated based things. The major concern in case of plant-based foods that plant-based alternative protein, that is the particular typical taste or flavor, that constraint can be overcome by the fermentation derived protein, and that's why I initially highlighted that there are chances or there are scope to develop protein conjugates, rather hybrid proteins, utilizing both fermentation and plant-based sources. Then the next one is the algae protein. I kept it separated. Algae can be cultivated, harvested, and dried, followed by cell disruption and separation to have particular isolation of protein. Then it is usually hydrolyzed by enzymatic reaction, and finally concentration and clarification is done to obtain the final protein isolates from algae sources. It is the one of the promising sources, one can say, because in case of lab-grown algae, that you can have a setup where you can grow the same food as that of in the thousands of acres, and that's why scientists are working brilliantly on this aspect. But it is still, as I told you, all this cultivated and this algae-based proteins are under study and research, because as more as you cultivate something within a closed periphery, there are chances of huge contamination with a single mistake, and some other aspects are also to be studied. The another thing or the another practical aspects why these are not in abundant these days, that is because of the gap in research as well as the commercialability of this technology as of now is not clear so far. So what is plant-based particularly? So all this composed of whatever the sources are there which are having protein in it, that can be said as the possible source. But what is promising source? So we have bifurcated few sources, of which I'm to highlight you in the next or upcoming slides what are the promising sources we can focus on. And my purpose in case of plant-based protein I am focused with is to highlight the indigenous sources, regional sources, which only can be considered as your cost-effective sources, your typically liked by the people of your area, a particular region, and that can be the promising thing and only thing by which alternative protein sector can grow and can be adaptable to Indian and Asian people particularly. So there are cereals, nuts which are already being consumed for protein and other starch and other energy purpose for our body. There are also oil seeds which are high in fats, of course, but when fats is removed, ultimately it will be rich in protein in case of fat-free mass. And the legumes, which are essentially the best source of protein in our diet, of course, and other also where 2 to 3, or I can say in micro to milligram of proteins are available. Friends, when it comes to plant-based protein, usually it is said as a poor source of essential amino acids. So this is a graphical representation of essential amino acid from bottom to top, and you can see the essential 7 to 9 acids are listed from bottom tryptophan to non-essential amino acid are also shown in this picture. So you can have an observation of your whatsoever the existing sources like mushrooms, soybean, and whey, and whatever the available sources as compared to the plant sources which we are in focus like peanut, oat, amaranth, your pea, soybean, everything. So a similar pattern or somewhere plus or minus you can see here. So that can be the conclusion where it is not like that a source is particularly highly rich in something and which is not rich in another thing, and that's why it should be adaptable or not adaptable. It is a clear-cut show for that. Let us focus more on our different plant sources where it is already in talk that essential amino acids are lower, but almost all the plant sources are not that much of rich in all kind of essential amino acids. Somewhat, the protein score, particularly PDCA score, which is highly considered as an important aspect. Other than PDCA score are also nowadays, but it is particularly the distribution of essential amino acids, which are somewhere plus or minus in each of the commodities. But soya, of course, it is rich in the first case. Otherwise, almost sources are in equal distribution in case of essential amino acids. And looking at this picture only, I am thought that to introduce indigenous crops in my research in commercial scale also to be adopted as a promising plant-based protein sources. Now, what is the actual distribution? Where the industry is in case of plant-based? So basically, two major products: plant-based dairy products and plant-based meat products are in abundance. The other remaining are also plant-based products where protein can be utilized, of course, but major is distributed in case of meat as a meat analogs and so preparation, and in case of dairy analogs preparation, particularly beverages and plant-based milk, cheese, paneer, everything. So a study shows that by time the growth of in billions is quite good, and somewhere it reaches to $161 billion or more than that even, if we can say the recent scenario. Now, what are the sources? Particularly, we are focused with the sources, and that's why. And why I focused on indigenous and pseudo-native crops, which are non-native, but since years it is being grown in the land of our country. So the benefits are it is a natural source, of course, and you can utilize the source without implications of high doses of chemicals, and so without any other influences in your land, you can grow it, and it is available. Majority of that available in the chemical-free environment. That is possible. The another aspect is the eco-friendly. Friends, majority of the indigenous sources in our study, being in agricultural universities, we found if the native crops are grown, if the indigenous crops are grown in our regional farming system, the system itself supports the growth of the your grains, but particularly plant-based sources, which are the promising sources for protein. Another aspect is the microflora, which is adjustable to your indigenous crops and quite helpful to grow in any environment, in any even harsh condition. It can be grown. So we rather focusing on some imported sources, importing from different countries and from different industries outside India, and then looking forward for price effectiveness and cost parity won't be possible. So you grow yourself your indigenous crops, which can be focused on, and our research should be focused on that only. So natural and eco-friendly, of course, and sustainable, because every now and then you require the abundant source. If I just go to the last slide, whatever the you have seen in this chart, the growth and the requirement, the growth would be double than this even, but it requires particular ingredients. And if the ingredients are totally outsourced, of course, your product won't match any kind of price parity. Other than this, also you have seen the GMO and so issues, where we have seen that no rejection to the final products which are being prepared in our country. So indigenous crops can ensure you non-GMO sources of protein. So these are the aspects. That's why we focused on sources, which are also divided in different aspects. You can say staple foods, your cereals, which are already sources of starch in measure, and of course, wheat gluten and rice protein is also in demand these days. Soybean is a promising, we can say, legume protein source for plant-based protein industry. And I joined it with peanut being a legume oilseed in case of category. So why I highlighted it, because next and upcoming slides will focus on why it is to be utilized. Then another is the chickpea, mung bean, and so pulses, which are also promising and can be utilized further. But the only thing is the technology is not being optimized, as well as it is not a cheaper source or cheaper way to produce protein. The another aspects are the maize and potato, which are more or less not having sufficient amount of protein that can be utilized as a promising source for alternative proteins. But of course, that can also be focused because of the indigenous and particularly availability. Looking into the market, the availability is quite huge. The another aspect, and this is what the current era where India is leading the world, that is the millets. Amaranth, sorry, amaranth and finger millet, because I focused with two millets only as of now in case of slide. It is abundantly available in our region, and that's why we are focused with the indigenous or regional research as well. So amaranth, in case of profiling, also we have found that it is having almost amino acids profile. It is quite rich and comparative to other millets which are available in our region. So amaranth and peanut both are the, I can say, highly focused in case of our research. The another aspects also covered hemp and cotton seeds, but the issues of toxicity and other unavoidable substances which should be removed, and research is still more required to work upon it. There are also other plant sources like moringa oil seed. Moringa seeds, if the oil is removed, it can also be a promising source. But again, as I told you, without any kind of research and further doing any job on it, it cannot be said as a promising source. So in case of our region, peas and beans and everything are not that much of a cheaper point where industry can rely upon, particularly plant-based protein ingredient and food product processing industries. So we have chosen peanut being, a byproduct as a protein-rich sources, particularly fetid peanut flour. And another is the amaranth, which is now grown in abundance and is a rich source of amino acids. So these two are more highlighted in that case. Now, we have also gone through some database and somewhat research studies at our level, and we found the true digestibility and PDCA score. How is the trend, particularly in case of different alternative plant-based protein ingredients, including current animal-based sources as well as current plant-based sources, and so. So you can easily see and distinguish the difference between the TDs and PDCAs, and you can come to conclusion that can be elevated or can be maintained by different processing technologies we do adopt. So far, this is what the database says, and what we work actually in case of for industrial purpose. My research is majority focused on the commerciality and applicability of ingredients at commercial level in the Indian and Asian food industries, which will be relying upon alternative proteins in future. So what major things I found in the industry that I am going to show you now. So the first challenge we face, that is the taste, and taste is dependent on three major aspects. How can we overcome this challenge? So first of all, identify the product where you want to apply. When you are developing an ingredient, the first challenge is the taste itself. So we need to identify the product. Either we are going to introduce our ingredients to meat analog processing industry, or any alternative beverage processing industry, or existing beverage like sports drinks and so industry, or it is for the particular purpose of dairy alternatives, or milk alternatives, or cheese alternatives or so. After identifying the product, cover up whatever the mask or the flavor flavor you can mask, of course, and the texture which is required by any means, by introducing a proper processing techniques or so. So optimizing according to the product, optimize your two factors, flavor and the texture of the product, which will directly affect your taste of the person who is consuming the product itself. And for what we have to do some research, and so, and after that, having that optimized condition for particular processing of ingredient, we have to finalize composition, or I can say the composition of different ingredients to produce a particular product, as well as the processing conditions under which the optimum product can be obtained. So first phase, that is the test, that can be covered in this aspect. The another challenge that we found while studying these different aspects of alternative processing industry and its promising future are the feasibility. Feasibility is a single section subdivided into four aspects, that is economical, technical, market, and operational. When it comes to economical, of course, the raw material, the availability of the raw material is highly focused, through which your a particular protein is available, and how much it is available. Then processing cost, that is the second aspect, and that's why in India, if you just go through any survey or just go through whatever the data available, you will find a number, only counted numbers of industry who are working in ingredient processing in case of plant-based protein. The another is the cost benefit ratio. After all this situation, ultimately the benefit should be to the producer itself, otherwise the industry won't be sustained. So this is the sustainable challenge, and that's why the second challenge, feasibility, is far more important. In case of technical aspects, so what I worked out throughout this period during which I am working with plant protein ingredients, the available technology are not sufficient, or I can say the conventional one, which can also be transformed to somewhat according to the requirement of the raw material and the stakeholders. The research gap is too much. You just have a look about it, that how much we are focused with ingredient development segment. Everyone is working with the final product development, and the ingredients are being hired either in the cheapest source where the quality won't be promised, and from the sources which are costlier. Everything is promised, but your product won't sustain in the market. So research gaps should be bridged, and somewhere efforts can be done mutually by the academia and the industry jointly to work out on it. Compatibility of ingredient is also an issue when it comes to product development, and that's why not all promising protein sources are utilized in final product development. The another aspect is the market. Actually, whenever R&Ds or work being done at universities or in the research institution, usually it is focused with the area where the university is. What is the actual market or demand? What they ask for? That never is focused, and that's why failures to whatsoever the outcomes are there we propose is usually found. So I again ask industries to come over and work upon it. They can idealize us and we can work out mutually for something better. The adaptability. If I develop something which is the best, but the adaptability is quite low, then what it won't work. So identifying the market criteria are much most important before finalizing any protein source. And the operational one that can be overcome by industries, of course, building a team with highly skilled people. It is not like a routine drying dehydrated product or flour making process. It requires a little skill and knowledge of what is going on. And the raw material availability, the operational factor is the utmost important. As I told you, raw material cost and availability will define whether your plant-based source is promising or not. In case of peanut that I focused on, of course, there may be some challenges which you have found in your literatures and even while googling. But of course, I must say peanut is a promising source because the availability of the raw material and the cost of the raw material both are promising, friends. It is a quite feasible source, and then that's why I focused on it. And the third and the most important challenge, if anyone can say, that is the existing sources functionality. Plant protein are high in use, of course, but are not still a sustainable source because of its functionality as well. It is the far more important, and we have found some solutions which are there in the literature and are listed here. There are a number of technologies which are available, which can, either or one or two or more than that functional properties can be modified, and your protein sources can be the promising source for meat and dairy analog industries. A few we can also discuss during our next presentation, ongoing presentation, but there are 10-12 technologies which are already there. But majority of these are still under study or under pilot scale level development, and that's where the challenge is. Now I rather focus on functionality because those two other are the industries can overcome, but functionality is where an R&D institution or an industry has to focus before entering to particular ingredient processing side. So depending on different applications of your ingredient, you have different functional properties which should be focused, and that are highlighted as a cross here in everywhere. So in different cases now, as the industry, for existence of the industry, every now and then novel products are being introduced. So those novel products are having somewhat functionality in their ingredient which make it perfect, or it looks like it confirms the standard of the product which are existing in the market. That's why. So I'm not going to focus on each and everything right now. And another is the functionality in terms of different properties. These are the four almost I can say important properties in functional terms which are associated with it. It is also a very good source if you identify few of these functional properties which should be focused in your research, and your research out something better in functional using different available or non-conventional techniques by which this can be improved. That could also make your ingredient particularly very promising in industry. Friends, whenever you work or research on it, of course, you keep into mind for a commercialization. Any technology, any non-conventional sources, if it is it cannot be converted into commercial scale, it won't work for the industry. In process, I can say where we can improve our production process. So but first of all, you need to know about the process side. What is the actual process being carried out? So there are 5 stages if any protein ingredient processing industry is to work on, and even R&D people. So first of all, the selection of raw material. So raw material characteristic would again be dependent on its post-harvest processing and how where to grow, how much is there. If it is not there, then what are the promising destinations where you can farm the product, raw material and the ingredients can be scaled up. So whenever it comes to commerciality, of course, the industry would require abundant quantity of raw material and its availability to nearby region. And that is at most first step to initiate for plant-based protein ingredient processing industry. The another is the extraction methodology, which is already discussed. Physical, chemical, enzymatic, and combine of one or two or three can be said as a method, promising method. Of course, I'm going to carry that in the next slide. But let's say physical case, in case of physical extraction, there are non-conventional techniques which physically you can implement it, and you can have separation of other components like starch or so by extraction, by removing fat, and so you can somewhere concentrate the protein in particular mass. Then go for the particular concentration by different techniques like precipitation, separation, and hydrolysis. Whatever what kind of ingredient you require at the end, and in applications of it. And furthermore, after having everything, you need to produce a fine flour of those protein, particularly protein mass. So drying technology can also be an area where we need to focus in case of R&D, which will directly affect your quality of the product and its application, particularly in the industry. So if I go for reverse engineering, again, focus on first applications. Then looking at your applications, looking at your products that you want to produce, looking at the promising market, and the scenario, identify its application, and after identification, go from raw material to final drying phase, and finally you will have your product. Let us focus more on plant-based protein extraction process flow. So initially, whatsoever sources, plant sources you have, it should be cleaned and dehulled. This is the routine process to remove non-digestible things or non-edible things from particular mass of grain. Then if it is having high oil content, oil should be extracted. It will go further for other utilization, and whatever the remaining defatted material is available with us, we will further go for either dry processing or wet processing. Of course, the extraction and so processes are of wet processing, but there are two ways: either by introducing, go for wet grinding or for dry grinding. So whatsoever you available, the protein rich flour which is available with you can further be extracted by alkali solubilization, where the pH can vary from 8 to 11.5, and the time for extraction may be from say from 10 minutes to 1.5 hours at different temperatures. So these are the parameters where R&D is focusing on. And this is the conventional process, I must say, rather in introducing to you. This is the conventional process one can do. What we have done, that will be in the coming slides. And whatever the protein is extracted, that should be separated from whatsoever the insoluble part, because majority of your protein will be soluble in that alkali phase. And after having that protein separation, it will again go for acid precipitation, and your precipitates will be collected, neutralized, and washed, and further spray dried to produce protein isolates. And whatever the remaining materials should also be processed. This is, friends, where industries now have to focus, not only protein, because out of your 100 kg, if this part is say 25-30 kg, so what about this remaining 70-80 kg? That also need to work out, right? So an industry, when it comes to commercialization of ingredient processing, these are also some hurdles to be overcome. So what exactly we do in case of protein extraction? Whatever your plant mass is available, and plant cells through which your protein is usually extracted with different processing. So this is the base. If the protein bodies are there, where protein either covered with any cell or any protein bodies, that is how we can strike on it in any way, in any method, by using any conventional, non-conventional extraction techniques. And the protein should be liberated, separated, and then isolated from that mass. So this is actually process to obtain protein isolates or concentrate. You disrupt the cells while protein is hidden within, and that protein again can be isolated from those mass to produce these isolates. So what in our case we have done so far, in case of production, we collected defeated peanut flour, which is the byproduct of oilseed processing industry, particularly groundnut oil processing industry, followed by a sequence of processes. I've already discussed. Some parameters are also given that we have optimized so far. And after extraction, we centrifuged the material, the sample which we were working upon, then precipitated, and followed by again centrifugation. The pellets were collected and the pH was neutralized, and particularly washed. The pellets were washed to obtain, the clear solution, which was dried and studied for its solubility and emulsification capacity. So performing, everything for more than 200, more than 200 to 50 times, and coming to a particular parameters, which give you the maximum, yield. First of all, that was our aspect. Then we checked through, the different analytical parts, and we found the solubility and emulsification capacity, which were our target traits. And what was that that I am showing you? So what we observed during our process, in case of, I can say that 200 to 250 times, following, different variations of the situations, temperature, pH, and other aspects. We obtain low yield in some cases, and majority of the yield is good. The solubility is quite poor. The other functional characteristics are also average to low, and then we found out through our research that these are the possible reason that hinders the quality of the final protein. That either the extraction was poor because of, as I shown in the slide, the rupture was not proper, or the way of rupturing was not proper, which ultimately, reduce our yield, particularly protein yield. Then acid alkali induced structural stresses, which causes, non-uniform particles, coarse particles, which reduces ultimately its functionality in the final product preparation. And the another aspect is the insoluble protein powder, because the powder was neutralized, the outcomes or pellets were neutralized, and that's why the solubility was poor in that case. So we worked out on different pathways which are available in the researches and in the surrounding. So I've gone through 4 aspects that 3 are the usual and 1 that I utilize in my research. In case of anyone who wants to, improve the functionality of plant-based protein concentrates or isolates, during processing, they can induce any of these treatments in their, process flow, and somewhere the changes they may obtain. So in case of physical, you can go for, heat, ultrasonication, high pressure processing, and so novel thermal technologies through which by any means your cells of the protein cells can be ruptured without damaging the particular the microstructure of the protein. The another ways are the chemical, which are conventional one, and some non-conventional are also listed here, but again the process is quite difficult. So acylation and succinylation, which are chemically modifying whatever the carboxyl group within the amino acids, and by which you can increase its functionality, particularly for a particular application. Phosphorylation is also one of the promising way in case of chemical process, and deamidation, of course. But these processes are usually in case of acylation, succinylation, and phosphorylation, chemically you are altering somewhat quality, and ultimately you can say chemically induced changes. In case of fibrillation, it is one of the novel aspect that one can work upon in case of alternative protein processing industry, which is quite interesting in case of whey protein concentration isolates being modified. So fibrillation is also one of the aspect in case of chemical processing. And other promising sources in case of plant-based protein functional improvement are the biological or enzymatic treatments that one can induce. And what we used is, out of these 3, we used physical and enzymatic treatment for further improvement of our final product. Now, I forgot it to tell you about the non-thermal modification. So, in case of non-thermal modification, where we have also utilized one of the technique in case of non-thermal processing. It is to induce by any means at micro level, disrupting the cells without damaging it chemically, without damaging its own structure. And that is the beauty of the non-thermal processing. That your final product would be, of that quality that its functionality won't be altered, and that's where you can work upon. So we introduced after the preparation of food, we introduced ultrasonication as a treatment, and enzyme also were added, and the further processes which were optimized were done as such. And finally, we obtained spray dried powder of protein, which was, I can say, more than 85% in case of protein. And the solubility were also analyzed, and incorporation and the studies are further going on by ourselves as well as different industries. Some pictures that I want to show you. Whatever we worked. Now, for another source, that is amaranth, that is also one of the promising source. And as we are promoting millets these days, so this is one of the important millets. We worked out some details about amaranth variety which are available with us, and the similar flowchart with somewhat trial and error cases, so as somewhat modification. So we modified a little, and we are now working with amaranth protein isolation and development of products from those isolates. So far, we have developed, we have optimized many of the things. Now the applications for development of different products is going on. So what we found in the case of peanut, that it is highly suitable for a majority of the dairy alternatives. While this, in case of amaranth and millets, of course, they are also having a promising, capacity in case of meat analogs as well. In case of amaranth protein concentrates development, we are focused with two aspects. As a commercial things, I can say optimization of yield, maximum yield should be optimized along with better functionality in these three aspects. We have also worked upon existing plant proteins, and we prepared omega-3 rich plant proteins, which are unique in sense in case of commercial availability. So what are the practical issues the industry would be facing, and for your knowledge as well, where that is these are the practical things we observed. I personally observed during my R&D era and these days. Raw material composition is of utmost important when it comes to your protein. So that is the finally affecting thing to optimize the product. Particularly different varietal changes and non-uniformity in case of quality would definitely affect your product processing, ingredient processing as well as product processing. The quality of curd is not that much better in every time when we repeated the experiment, and these are the essential aspects that industry should know about, where the issues are there and where the challenges are there. To obtain a particular hard curd like the soya, in case of soya and others, that is also utmost important, because when the curd is of good quality, your further processing and the ingredient quality is also would be better. And the sludge, the more aspect, I can say one more aspect that industry should focus is how to handle that remaining part other than protein, because it is utilizing more than 10 times of water. Every now and then you are introducing 10 times of water, and the remaining the solids part, particularly in that water extract that is obtained after achieving curd and protein, so that is also a hurdle, or I can say hindering part for commercialization of this plant protein. The another aspect is drying. Majority we people are focused with protein and so things, but we forget that drying operation is definitely one of the components that one should optimize during the processing and commercial scalability. If one go for freeze drying and so aspect, I don't think so it would be commercialized and the cost effective way for any kind of plant protein commercial production. So drying should also be properly managed in case of parameters to obtain a particular product. The later one is the functionality. Of course, it is already discussed. Functionality is one of the major challenges that plant protein do face in case of utilization in food product development, and the applicability, that is the market scenario aspect. And applications, I have found out few applications by exploring the industries and developing some more products at our stage as well. So applications are abundant, friends. We only focused with meat and dairy alternatives, but there are a number of applications where these plant protein based ingredients can be utilized. First of all, is the, we can say, preparation of beverages of any kind. So you are aware about it is routine in news, sparkling beverages and sports beverages, which are now where plant-based ingredients are introduced. The low glycemic floors, diabetes is the major challenge in our country as well as in other countries in the rest of the world as well. So those people, and particularly developing flours which are low in starch, which are good in protein. So this protein will not only work with the quality protein, not only work with a protein increment, but also it has typical characteristic that can be supplied and utilized as a flour source mixed with the another starch and other flours. So low glycemic flours can also be prepared by incorporating the plant proteins. Another is the peanut butter, where our applications are successful applications have been made so far to produce high protein peanut butter. Then dairy analogs, of course, as of now only soy. Other than these are the badam milk and so available in the market. Friends, high protein flours, not other than even concentrates, can also be the promising ingredient to produce dairy analogs. Particularly, plant sources are promising in case of cheese analogs and paneer analogs development, and it is being utilized. And not only that, even egg analogs can also be prepared, and that is dependent on the functionality of the ingredient you process. And another aspect is the texture flour preparation. It is high in demand these days. Texturization of the low moisture extrusion, or that is also one of the technology available to produce textured flour, which extrusion, it is the high heat processing by which you can produce some better quality or better functionality of flour for your final product preparation. And it is being there, but only soy is the major ingredient these days. Then high protein snacks can also be produced using this alternative proteins, particularly plant-based proteins. And bakery industry, where only one or two components which are high in protein can be utilized. This also can be a promising source, and industries are already in adopting our suggestions to develop bakery products which are high in plant-based protein. And when it comes to commerciality, there is one study, and so far we have our concepts that the protein and the quality and everything we focus on PDCAS and so. But friends, this is the real picture in scaling up the plant protein processing segment or food products. Usually, these are the aspects which are more than 50% of focus when it comes to commerciality. So taste is utmost important. Since beginning we are talking about the quality of protein, of course. The naturality of the ingredients, that is also, if highly processed ingredients are there, then also it is not that much of an adoption in case of commerciality. The cost of the product is one of the top 5 aspects that can be considered, and the amount of protein per serving. Then flavor of the product. So working on this more than 50% aspect would be the future of alternative protein processing industry in India. And also we being in the country where plant-based food is abundant in use, we are not fighting with any dairy or any meat industry. We are serving something best. We are serving something better in case of protein and the future of food by adopting plant-based protein. Okay, so this is up to this where I want to highlight. I think I took few more minutes. I'm sorry for that. For any further, interest or any further deliberation, you are welcome to connect me. Thank you so much.
Thank you, sir. No problem if it took a little more time. Thank you so much. If anyone has any questions, the floor is open. You can put it in chat box or unmute yourself. So, sir, when you mention amaranth protein flour, so what is the is it the protein percentage is similar to what we see in soy?
No, see, amaranth or millets, which are also good source of protein, of course, but it is not like it is having only protein. We need, few more exercise we have to do. It is like soy or peanut are what oil seeds in measure. So oil is the fatty substance is the major source, but when it comes to millet, fiber source it is a source of fiber as well. So fiber would be an hindering part when it was there in the R&D side. So it is not only rich in protein, it is having a measure in case of fibers and starch and carbohydrates particularly. But yes, it is a promising source. It can be further utilized.
Okay, thank you. So we have a question. How do you keep the chemical processing to minimum and yet try to achieve high protein content?
So I already briefed few aspects like physical treatment as well as enzymatic treatment. There are abundant material available that you can refer for your development of product. Chemically, it is the conventional method. Otherwise, non-conventional sources as well as possible as maximum as possible go for physical separation or introduce physical sources along with enzymatic and so treatment that would disrupt your ultimate goal is to disrupt the cells where protein is hidden. So by chemically, 100% chemically, of course, your product quality and everything, it is, I can say, not advisable. And that's why the other sources to obtain a good quality of protein other than chemical, of course, there are non-conventional but practical physical treatments along with enzyme that could also be a promising way. Thank you.
Sir. Hello, sir.
Yes.
Sir, I have one question. What are the formulating challenges associated with plant protein processing?
Yeah. What are the
Formulating challenges associated with plant protein processing during the processing? Like, what are the challenges?
practically? I already took in my slides. These are the practical issues. Even not only an R&D person, but an industry would definitely face. And practically it can be overcome by introducing small changes at different processing level. These are the featured, I can say, as you asked, featured issues that we definitely will have when it comes to plant protein processing.
Okay, one last interesting question is, can we utilize plant-based protein for formulation of space food? So
yeah,
maybe
that could be an interesting study if someone go for. So far, we work what the inquiries are available with us. So if any space food industry or space food processing industry would approach to us, we'll definitely work out on this aspect.
Okay. Okay, I think we are done with questions. I would request Anjali to raise a vote of thanks.
Thank you so much, sir, for this very valuable session and interesting insights which you shared with us in this webinar. On behalf of CSMB and everyone, we thank you for today's webinar, sir. Thank you so much.
Thank you
Thank
so
you,
much
everyone.
for your invitation. And of course, whoever are attending or whoever will attend on YouTube, definitely they are requested to approach to me for any one-to-one discussion anytime. Just either WhatsApp me or mail me as mentioned. And whatever new or interesting insight would be there would be shared on definitely on LinkedIn. So be active on it. And I thank organizers particularly for giving this opportunity and highlighting to the people. And more we would draw the attention of the people by promoting in different ways and aspects wherever possible. Thank you so much.
Yes, sir, definitely. Thank you so much. Thank you, everyone, for joining.